All right. Good morning, everyone. Let's see. And thank you, everyone, for joining. And sorry for the confusion about the start time of the webinar. Okay, I can't start my video, so you won't be able to see me. Okay. Well, at least my name is Birgir. I'm going to introduce this webinar. Yeah, sorry, I'm trying to start my video, but it says the host has blocked the video. But that's okay. Okay, my name is Birgir. I'm going to start this first webinar of these 4 projects that I will tell you just a little bit about in a minute. So this first one is called Horizon. Well, the series is called Horizon for Proteins. So this is a joint series of webinars by these 4 projects. This is the first one, which we have named Safety and Regulatory of Novel Proteins. We will have two presentations here today. We will have 2 presentations here today, which I will also introduce in a minute. But first, I want to give you just a very short background on why we are doing this, why we are having this webinar series, why these projects exist, and what we hope to achieve with these projects and these webinar series. So, as we all might know, the access to high quality, sustainably produced proteins is becoming increasingly restricted due to a number of reasons. You could name growing world population, increased pressure, natural resources, climate change, while at the same time the global protein demand has never been higher. And to meet this increasing demand, the protein production or food production in general will need to double by 2050. And in addition, Europe is not really self-sufficient when it comes to protein production. About 70% of proteins, mainly 70 to 80% for feed, is imported, mainly from South America, and with very high concerns about the competitiveness of the EU and general sustainability. So that's where this call called Alternative Proteins for Food and Feed by the Horizon 2020 program was announced, and we applied for in 2019, and these 4 projects got funded. So what are these 4 projects? First, we have a project called SUSINCHAIN, Sustainable Insect Chain, which aims to contribute to novel protein provision for feed and food in Europe by overcoming the remaining barriers for increasing the economic viability of the insect value chain. So they are focusing on insects. We have the ProFuture project, which aims at to scale up microalgae production and prepare the market uptake of microalgae proteins as ingredients for innovative and sustainable food and feed products. We got the Smart Protein project, which aims to develop alternative protein ingredients and products for humans which have a positive impact on the bioeconomy, environment, biodiversity, nutrition, food security, and consumer trust and acceptance. And lastly, we have okay. me try to share again if the slides have disappeared. I'm sorry for that. Are these slides visible now? I don't know what happened. Okay.
For me, they are. Yeah.
Okay, they are. Okay, great. I'm sorry. So I don't know where you lost them, but I was going over the 4 projects. We already went over the SUSINCHAIN project, the ProFuture project, Smart Protein, and we were now introducing NextGenProteins, which is will optimize, validate, and in an industrially relevant environment the production of proteins from microalgae, single cells, and insects, and demonstrate their suitability or as addition to traditional protein sources in food and feed value chains. So we kind of look at the projects as a part of this revolution in meeting the world's protein demand in a sustainable way, increasing the availability of high quality alternative proteins from underutilized resources, increase consumer trust and acceptability, and promote market adoption, and in the long term impact the food sector by providing credible, sustainable alternative proteins for use in various food and feed products. So today we have the first joint panel by these projects, which has been named Horizon for Proteins, the general name for the panels. And the first one is on safety and regulatory of novel protein sources. We will have 2 speakers. Firstly, Professor Sveinn Agnarsson, which is a professor of economics at the Faculty of Business Administration, University of Iceland. He will give us a talk about the regulatory challenges of alternative proteins. And then we will hear from Professor Ine van der Vels, which is an expert group leader, AgroChain's special professor, food safety and economics, Department of Business in Wageningen University. And I think and then we after this we will have Q&A sessions, which will be roughly from 10:50 to 11. And I think without further ado, I will introduce the first speaker, so Sveinn Agnarsson, if you are ready. Please start. I will stop my slides and you can share yours.
Are my files visible?
Yes, when we can see your slide, but not in presentation mode yet. And if you could speak that, could you speak a little bit louder? Your voice is very deep. Thank you.
So. Thank you, everyone. So I'm going to. My name is Sveinn Agnarsson. I represent the.
Sveinn, sorry to interrupt, but we can barely hear you. Is there anything you could do regarding the sound?
Is it better now?
Yes, much better.
Okay, I will try to speak. Do it this way then. Okay, so my name is Sveinn Agnarsson, and I represent Sjókovin, the Blue Resource it's a Faroese firm. I'm also working at the University of Iceland. So I want to give you some insight into results that we are obtaining and have been obtaining from our work in this NextGenProteins. So let me start. I hope you can see my screen.
Yes. Yes.
Okay, so let me continue and briefly look at the objectives of the project. Now, as Birgir had just explained, the aim of NextGenProteins is regarding the production is threefold. First, to optimize and validate the production of proteins from microalgae, single cells, and insects. And secondly, to demonstrate the suitability of these proteins as addition to or substitute of more traditional protein sources in food and feed value chains. And then, as a part of that, to contribute to strengthening food security, sustainability, and self-sufficiency of the EU protein production. And the other objectives, which I'm going to be talking a little bit more about, are to assess food and feed regulatory and safety landscape in Europe, identify main barriers for production and application of the three alternative proteins. And it is our aim that we will, towards the end of the project and after the project, be able to contribute to future European Union policy in the area. Now, I think it might be useful to start by looking at the underlying principles regarding novel food in the European Union. Now, there are three cornerstones that I think we should mention first. The novel food must be safe for consumers, and that is very, very clear from the regulation that the European Union has adopted. Properly labeled so as that consumers are not misled. And if novel food is intended to replace another food, it must not differ in a way such that the consumption of the novel food would be nutritionally disadvantageous for the consumer. And the pre-market authorization is very much in line with these principles. In NextGenProteins, of course, we are focusing primarily on production of proteins, but we're also very much concerned, like I said, with the regulation and the barriers to production. And for our purposes, we have been conducting interviews both with people that are taking part in the project, internal stakeholders from industry, the industry partners which are associated with NextGenProteins. And then starting this summer, we launched a very extensive work on consultation with external stakeholders. We have been talking to people at different levels in Europe, ministries, authorities, associations, both producers associations and consumers. We have so far reached out to around 30 external stakeholders. We hope to add a little more to that before we finish. The 7 countries includes the EU, of course, and then Germany, Italy, Finland, the UK, Sweden, Iceland, and the Faroe Islands. And we will hopefully be able to add to that a little bit. From these interviews, we have been gathering information on how these people regard the regulatory framework that they are operating within, and how they would like to, what changes they would like to see, if any. And the surveys, the interviews that we have been conducting are quite far-reaching. And what I want to present to you today is just a part of the results, but that may focus quite well on the aims of this webinar today. Now, what we have been seeing when we regard the interviews with our industry partners and talking about these regulatory challenges that they see. First of all, they focus on the fact that there is need to harmonize globally the novel food regulations. At the moment, it's not the same everywhere, and they feel that this is very much hindering development in the area, innovation, etc., and also competitiveness. They meaning the industry partners. The industry partners have also pointed out that the preparation of dossiers is very expensive and very time consuming, and that these regulations that they have observed can very easily become serious trade barriers. And they're also focusing a little bit on the retail, how the retail trade operators behave, that in addition to the difficulties or challenges that the regulatory framework consists of, then there are also these difficulties in the fact that the retail trade operators, they may have internal guidelines where they specify quality limits and requirements for the products, for instance, and these may differ from the legislative limits. And these are difficulties that some of our industry partners have been pointing out. I also want to mention, although it doesn't fall directly under this, a little bit about the consumer challenges that our industry partners have been identifying. Now, they regard, of course, the consumer health of utmost importance. And there is huge need when presenting these products to consumers for scientific information on toxicology, allergens, microbiological and chemical safety, and of course on the quality. And in this modern world, traceability and labeling of the products so that consumers know where the product comes from and what it contains is hugely important. And this, of course, is very much in line with what the European Commission and authorities have been saying on the importance of safety. There is also the technological performance, the nutritional aspects and sensory quality of the new alternative proteins that is important, and this must be acceptable for application. So the consumers, how they sense the product, of course, is very, very important. It is clear that organic certificates would benefit these industrial partners in food applications. And our stakeholders have also mentioned frequently that education of consumers and farmers and other stakeholders should be improved, that people need more information on these new protein sources, on the sustainability issues, the eco footprint, the LCA, safety, nutritional value. When consumers are facing a new product, they tend to be hesitant. So the more information available, the better. The stakeholders that we have been talking to have been mentioning that it would be good, for instance, to have some kind of a coalition of alternative protein producers and other stakeholders that could be a good platform for sharing information on sustainability and other important issues. So these are the views that we have been gathering from our people. Now, if we look at the standard procedure for novel food authorization, and we realize, of course, that that when the application for authorization is sent to the Commission, and then the Commission has to determine whether it needs EFSA opinion or not. Now, if it does need EFSA opinion, then of course the producers must transmit dossiers within a month, and then EFSA has a further 9 months to deliberate their decision. And after that, the Commission draft decision can come after 7 months. So in all, there is a 17-month period. And during these periods, of course, if EFSA, for instance, regards the dossier as incomplete, as further information is needed, then the clock will stop. and the time will not continue. The 9 month period can become much longer if there are if more information needs to be added to the dossiers. And this, of course, the length of the time and the clock stop. It has been people have been very critical of that. Now, we have also, like I said, been talking to these 30 stakeholders that are outside our project. And if we look at what they have been saying on how they can accelerate the regulatory process and approval, then it's clear that improved guidance and clarity on the information needed to submit a dossier. There should be clearer definitions, greater transparency. There have also been calls for shorter evaluation periods. Others have been saying that the producers, they must improve their research. The more data that they have available, the more evidence that they can produce, the quicker it will be for EFSA to make up their mind and come to a decision. Others have been pointing out that perhaps this bottom-up approach, where you have all these firms putting forward their products, may be wrong, that we should perhaps instead adopt a top-down approach and decide which protein should be developed and deliver clear requirements and safety manufacturing framework. Related to these are the fact that there is great emphasis on safety. And that, of course, does mean that all evaluation and assessment will take time. And therefore, like I mentioned before, the quality of the proposal submitted is essential. Some people have been mentioning that because risk assessment is very, very time consuming, that EFSA may be understaffed in this area. So that could be helped by increasing the staff. But also, like I mentioned before, there are different regulatory speeds in Europe and outside Europe. And this brings about the risk that the competitiveness of the European industry may be harmed. There are also, I noticed that some people were saying that by nature, bureaucracy is heavy and slow, and that's the idea of the system. So possibly we shouldn't be surprised that it is slow, but that is just how bureaucracy tends to work. There is also, what are the biggest challenges in terms of regulation? The amount of science and evidence needed, and linked to that, because it takes time, because of the monumental task involved in compiling these dossiers, the firms have to be economically very, very strong. There is also the fact that the regulation process is ineffective. People have been complaining about that. And then pointing out that increased training and education of control authorities needs to be improved. And the fact is, of course, that innovation often proceeds faster than what regulations can adapt to, and therefore training and education must be constantly improved. But then, interestingly enough, there were also people who have been mentioning how activists, lobbying activities of other producers of more traditional proteins can impact on regulation. So what then could we see as future improvements that could facilitate cooperation between industry and authorities? Well, first of all, we have to realize that exchange and mutual information is extremely important. It might be good to have some kind of a neutral venue or a speaker that could mediate between industry and authorities. We need to have a good dialogue, regular meetings with firms and industry associations. Above all, I think what came out of it is that very many people have been talking about the need of transparency and sharing of information, and the trust and willingness to cooperate at high levels. But also, and this I think is very important, we are talking about how we can move our societies more towards sustainability, how we can combat the environmental problems that we are facing. And this, some have pointed out that authorities all over the world need to recognize that agricultural and food turnaround is just as important in this respect as the transport and energy transition that people have been talking about. And that, I think, brings my contribution to a close. Thank you very much.
Thank you very much, Sveinn. Nice picture there at the end. We will now get a presentation from Ina van der Vels. And also to mention that we will answer the questions from the chat afterwards in the Q&A session after Ina is done. So Ina, please.
Okay, thank you, Birger. Let me see how I can share my screen. Or can my slides put up here?
Yeah, you can share your screen.
And you can turn on your camera now. Well,
I can turn on my camera, yeah. But I cannot share my screen somehow.
That's really nice. Now it works. Maybe
Now it
everybody
works
can
all of a
try to.
sudden. But Anna, can you put up on the
Ah, nice.
finally.
Finally,
Oh, here it is. Here it is. Sorry, I have it.
It's a bit weird only to speak in a black.
Yeah.
Yeah, I thought it was a bit weird
Yeah.
when I was starting. So Ina, we
Yeah.
can see your slides now.
Ah,
If you can
great.
put them
great.
in
Yeah, the
presentation mode.
presenting mode. If that works. 1 second. Okay, there we go. So yes, my name is Ine van der Vels. I work as a senior scientist at Wageningen Food Safety Research in Wageningen, the Netherlands. And I also work at Wageningen University as a special professor in food safety economics. And today I will present a little bit of our work in the SUSINCHAIN project. The work I present is performed in work package 6 of this project, and work package 6 focuses on the safety of rearing insects. A little bit of background.
I'm sorry to interrupt, but at least for me, the slides are not moving and not in presentation mode. Maybe it's just for me.
Okay, great.
Can you try to share again, maybe?
Yeah, stop share and share again. Then. Can you see them now?
Yep, but not in presentation mode.
Also not again. Yeah, somehow it doesn't work. Maybe we stick to this one.
It's okay.
See if they're moving. You
Yeah,
see the
they're
second
moving.
one? Yeah, okay. So yeah, as you also heard in the previous presentation, when upscaling the insect value chain, the safety of the projects need to be ensured. And that means that we have to follow a safe by design approach rather than end of pipe. That means that we have to work on the safety of the products before putting them on the market and also in the early stage of development. With rearing of insects, the substrates can contain different microbial and chemical hazards. They can be below regulatory limits. But since we do not know what happens in the insect's body, we need to investigate if there is any accumulation or excretion or whatsoever in the insect larvae. So the objective of work package 6 of the SUSINCHAIN project is to investigate the possible accumulation of microbial and chemical hazards from the substrate into the insect larvae. And in this presentation, I focus on the chemical hazards and more in particular on mycotoxins. And mycotoxins are toxins produced by fungi on agricultural crops, and they are very toxic to animal and human health. From previous research, the mycotoxins seem to be degraded by insects, so not to accumulate in insect larvae, but like they seem to break down. But we do not know the metabolic pathway, so what compounds are formed then by the insect larvae, and also not their toxicity. And we have to know these because, of course, okay, if mycotoxins are not present in the larvae, what compounds are formed by the larvae from the mycotoxins, and are they also not as toxic as mycotoxins? So that is what we want to investigate in this work package. And we did 2 experiments at WFSR, one with a lesser mealworm and one with black shoulder fly. So the methodology is for both experiments that we spike mycotoxins to the substrate of that we give to the larvae in different concentrations. We rear the insects on the spiked substrates. And then we investigate the effects on the growth and the survival of the larvae. And also we do chemical analysis of the mycotoxins in the insect larvae after harvest and the residual material. And of course, as a control also, we check the spiked concentration in the substrates. When doing the analysis, we both do the LCMS analysis for the known mycotoxins and known mycotoxin metabolites, but we also performed a high resolution mass spectrometry to find any secondary metabolite present. And in the end, we do mass balance calculations to see if there is accumulation or metabolization. This slide shows the methodology for the high resolution mass spectrometry analysis. It gives, if you look at the bottom of the slide, you see the mass. So this method, this chemical method, looks at, you can see what are the masses of the compounds in a certain sample. Based on the masses, you can look, investigate what could be a possible formula, and then you can go up to level 1. As you can see here, in the end, you want to have a confirmed structure and a compound. So you have here, from this type of analysis, you have different levels of certainty on what you can detect. If a certain compound, you can, in the worst case, you only have a mass. In the best case, you have a confirmed compound. So the mycotoxin experiment with the lesser mealworms, we spiked the substrate of the lesser mealworms with 2 different concentrations, so 200 and 600 microgram per kilogram. We performed the experiment at the Protefarm company in 3 phases of the insect, so the larvae, the prepupae, and the beetles. We harvested the insects, and as I explained, we did the chemical analysis of the larvae, the residual materials, and the substrate. Well, the first results showed that there was no effect at all on the growth and the survival. We looked at aflatoxin B1 at 2 different concentrates. The known metabolites that were investigated are aflatoxin B1, M1, P1, Q1, and aflatoxin chol. So for these metabolites, we have standards in the lab, and we can really analyze them very accurately. In the larvae, none of these metabolites was present below the limit of quantification, above the limit of quantification. And in the frass, so the residual material, 2 of them were slightly present above the limit of quantification, so very low concentrations. And aflatoxin B1, so the mycotoxin that we spiked to the substrate, was around 0.6 of the concentration that was added. For the secondary metabolites, so the unknown ones, we could not identify any of the secondary metabolites in the larvae. And in the frass, we could see there was some kind of metabolites which had the aflatoxin B1 plus an O group or H2SO4 group added. This slide shows the mass balance for the lesser mealworm, and what you can see here is you have the 3 different stages of the insect, so D14, D27, and D48. and the two different concentrations that were spiked. So 200 microgram per kilogram and 600 microgram per kilogram. And the overall picture shows that from all the aflatoxin that we added to the substrate, we could only find back 25 to 40% at the max. So even though including the known metabolites, well, over 50% could not be detected anymore, which means there is a kind of a metabolization of this aflatoxin, and it's broken down in other compounds. But we still cannot say which compounds that are exactly. Then we move to the black soldier fly experiment. It's kind of a similar approach, except that in this case, we used 4 different mycotoxins. So aflatoxin B1, fumonisin, ochratoxin A, and zearalenone. And in this experiment, we added the mycotoxins, but also the isotope labeled form. And the idea of doing the experiment with isotope labeled form is that we can follow the mycotoxin more precisely in the analysis. And the same case here, we did chemical analysis of the substrate, the larvae, and the residual material, and we calculated the mass balance. And we used both LCMS method and the high resolution MS method. This experiment was performed at Bestico company, and we used larvae of D7 to 14. So in this case, 1 life stage, but 4 different mycotoxins, whereas with the lesser mealworm, we had different life stages and 1 mycotoxin. The experiment showed that insects were doing really well. There was no effect of the mycotoxins on the growth and the survival of the insects. When we look at the chemical analysis, we could see that all 4 parent compounds, so the 4 mycotoxins that we had added, could be quantified. So they were present, but in very low concentrations in the larvae. The accumulation of the mycotoxins into the larvae, so from the substrate into the larvae, was very low, so nearly 0. But only for fumonisins we find some accumulation, but still below 1. So the concentration was still in the larvae was still much lower than in the substrate. And the results from the LCMS showed that we could detect some of the metabolites from the parent compounds, which were aflatoxin P1, that was the metabolite from aflatoxin B1, ochratoxin alpha from OTA, and then for zearalenone we find 2 metabolites, alpha and beta zearalenone. When we look at the frass, we also found these 4 mycotoxins that we had added to the substrate, and then in higher concentrations than in the larvae. We found similar metabolites as in the larvae, and also 1 more, which was ochratoxin B. And from the high resolution mass spectrometry, we could find some secondary metabolites related to zearalenone, but it was unclear which ones these were. So we could not identify the compounds. Then the mass balance for the 4 different mycotoxins. And what you can see from this mass balance is that also in this case, aflatoxin B1, it was around 70%, which means it was higher than with the lesser mealworm, where we were below 40%. So that means here, in this case, we could find back 70% of the aflatoxin B1 that we added to the substrate, we could find back in the larvae. For fumonisins, it was around 40%, but for ochratoxin A and zearalenone, it was 100%. So here we can, for those 2 mycotoxins, the pattern of the metabolism is clear, and we could find back all the toxins that we added. So there's a difference between ochratoxin A and zearalenone at the one hand, and fumonisin B1 and aflatoxin B1 at the other hand. So overall, when we look at those 2 experiments, we we clearly saw no effects of mycotoxins on the growth and survival of both black soldier fly and lesser mealworm. And this is consistent with other studies, but it shows that insects can grow and do well on high concentrations of mycotoxins in the substrate. The mycotoxins that we had added to the substrate were absent or in very low concentrations were found back in the larvae. So also they do not accumulate mycotoxins from the substrate. And then if we look at the metabolites, we found some difference between the two methods that we had used. So LCMS for no metabolites and high resolution MS. And that may have to do with the lower sensitivity of the high resolution mass spectrometry compared to LCMS. And in the end, for aflatoxin B1 and fumonisin, the mass balance was not complete. This study did not give any additional insights on what metabolites could have been formed. There are only a few more insights from what we know from previous research. So it means, even though that we had used isotope labeled mycotoxins, and that means that we will move to the next step and we will perform toxicity studies instead of using these experiments. Conclusions. The conclusion is you could see from the differences in the mycotoxins, the accumulation and the mass balance, that these are very case specific. So we need a safe by design approach for bringing insects to the market. And that means that the accumulation of the metabolization are very specific on the species of the insects and also the hazard that you look at. So even though within the group of mycotoxins, we already found differences. So it needs a case-specific approach, meaning that you have to investigate the different hazards that can be present in the different insect species and the substrate that they are being given. Regarding the possible breakdown mechanisms of mycotoxins, it can provide great opportunities because if we have mycotoxin contaminated agricultural crops which cannot be used for feed or food production, they can be given to insects, for instance. We show that they do very well on these contaminated crops. The growth and survival is not affected. And also the mycotoxins do not accumulate in the larvae. So that's all very promising, but we need to investigate what happens in the insect larvae. We need to investigate the metabolism before we can really be sure to say that these products, these larvae are safe, because we don't know what happens. So we don't know what other metabolite could have been formed. And that we want to achieve now with toxicity studies. And that brings me to the end of my presentation. I would like to thank the people involved from Wageningen Food Safety Research, my colleagues Nathan, Rosalie, Ed, and many others in the lab. And the people from the two companies involved, Bestico and ProFuture. So Lisa Soet and Malou Bos, who helped really a lot with the experiments. And I give you back the word, Birger.
Thank you, Ina, for this very interesting presentation. So now we heard from both of our presentations, and I want to give the word to Rosemary and Dario for the Q&A. So please take over the Q&A and maybe introduce yourself shortly.
Okay, maybe I start right away. My name is Rosemary Royce, and I'm from Eura AG and based in Berlin. And I'm the work package leader of the business development of the Smart Protein project. And in this function, I was also concerned of laws and regulations for sure. And so we had a bit the same discussions I heard right now. So the problems you all mentioned now in your presentations are quite familiar to us. And this even reconforts me to say that we all end up with the same conclusions, and we end up with the same problems, and we face the same challenges. So this is on the one hand the good news, but on the other hand, it strengthens the importance that we really have to talk to the authorities if we want to bring forward the new proteins, the smart proteins, the alternative proteins, where however you call them, there is a really critical break in moving forward by all these problems. So Dario, up to you.
Yes, thanks. Hello to all of you. I'm Dario Dongo, and I'm a food lawyer since working since 30 years ago on food and agricultural policies at European level. And indeed, I'm pretty optimistic looking at the same issues you've been talking about from a regulatory perspective. I see there's an interesting evolution of the rules since the novel food regulation was started in 1997 with Regulation 258. We've registered a state development over the last years, and I mean that Regulation 2283 year 2015 has dramatically improved the process, and despite the timelines as Svein anticipated aren't always followed, and the process is going. And what I noticed, we thanks to the transparency regulation, we have access to a number of dossiers. So we have the concrete possibility to study each dossier and to understand by categories of novel foods that have been authorized, which are the missing points in dossiers or the lags to be covered. So, for example, I really appreciated both presentations, and I was curious about, in particular, about Ine's presentation on the toxicological aspects related to insects, because we're working on a novel food authorization regarding Achata domesticus. And as I see, we find even more and more clearance on, we have everyday clearer information about how to deal with these dossiers, thanks to either the guidelines that EFSA has provided and the precedent dossier. So what I see, once presenting a novel dossier was somehow a jump in the dark, whereas nowadays we have a very clear path to follow, even when deciding, for example, how many samples to examine and most of parameters. So I'm very positive, and I believe that even industry partners perplexities ought to be understood, but also industry partners ought to be encouraged to bring forward novel food authorization. It is true that there's no global agreement on novel food procedure, but this is obvious, because the the food systems are so difficult, so different from an area to the other. My PhD thesis was dedicated to the value of the European food law and the impact it has had on the Gulf food law, so Gulf countries food law, on the North American one and the Chinese one. It is true that we are providing worldwide guidance, but the systems are still different. Nonetheless, there is a good chance to go forward, and it is also to be considered that we're talking about a real revolution in food systems, and we cannot expect that scientific evaluation of risks can be performed so easily. I mean, you are scientists, and you more than anyone else can understand which are the challenges that are biological and microbiological, but also chemicals. We notice, for example, some problems with biological amines in some insects analysis, probably due to poor breeding manufacturing practices. So we must consider all the problems, as well as the insects feed can also have an impact on allergenic reactions, which has also to be considered. And we're talking about the perspective of progressively substituting, because this is our aim, unsustainable protein sources like the South American soy with novel proteins, novel sources of protein. So it is, I believe it is obvious that we must be careful when
Dario,
yeah.
Dario, the allergenicity of insect proteins is also investigated in the SUSINCHAIN project.
Yes, I know that. I would just mention in this point, because it is also one of the aspects to be considered, as well as the heavy metals that luckily don't seem to be a real problem. But from a regulatory perspective, the encouragement is full, because I see there's a great space for innovation being developed at the European level. I agree that there's probably a problem of understaffing of European Food Safety Authority. We have evidence of it, because we've had some difficulties in getting the copies of some dossiers over the last months, even, for example, on CBD, hemp derived product. But this depends also on the European Food Safety Authority's budget, which is decided every year by the European Parliament. So that was my humble point of view, and I see. Emanuele Zanini, that thanks everyone. I was looking whether there's any question from the chat.
There's a question, I think, in the Rosemary, please take it.
On the price, yeah, because this, I think, as I'm coming not from the legal part, but more or less from the business part of point of view, this would also have been my first question. how is the development on the price structure when you have to do a novel food assessment? And does it differ a lot from product to product, or can we say that there is a general price frame, or what companies have to count on?
Are you talking to me? Or
Yeah.
Okay.
Do you know about the?
Yeah. Actually,
that was one question in our chat.
Actually,
Cost
there's
structure.
there's no fixed tariff. Let's say the basic question is there any experience of consumption in third countries of a certain product? This question provides us a first possible answer. As we saw in the first insects novel food authorizations, the existence of experience of consumption in third countries was considered enough in order to skip toxicological analysis in terms of long-term effects and carcinogenic effects. So EFSA actually has found an intermediate position between an ordinary novel food procedure and a simplified procedure, whereas the latter is provided wherever a candidate novel food has an experience of consumption or a tradition of safe consumption in third countries. This intermediate position helped the applicants not to provide very costly studies. So I would say this: there's no tariffs. The price, the cost of a novel food application mostly depends on the cost of analysis that have to be performed in order to assess the safety of a product, and also it depends on the available scientific literature, because some products have an abundant scientific literature already providing an appreciable assessment of their safety. Therefore, on basis of this, more or less simple analysis can be performed on product batches of the applicant to be added to the description of a process, the good manufacturing practices, the HSSF analysis, and the dossier is made. Whereas innovative process obviously require more attention as it regards to provide evidence of the safety of each phases. But as far as I see, I would surely allocate a great bunch of money in order to prepare a dossier of authorization for cellular agriculture of cell agriculture of animal proteins, because in that area innovation is truly impacting, and the possible impact on the food chain would be potentially dramatic. Whereas novel food dossiers in areas like which are very actual for new proteins development, like insects or microalgae, or also seaweed, macroalgae, in my view, nowadays are truly affordable, and they can be seen as innovation investment, as the natural output of an R&D investment by any food business operator. And I would also add that the actual data management policy, which is being brought forward by the European Commission, ought to, as I'm trying to share within the Horizon 2020 projects we are involved in, ought to help knowledge sharing and to provide to the general public and to the interested stakeholders more evidence that might be used in order to provide scientific assessment on novel food authorization dossier. So the knowledge sharing that the new data management policies are promoting ought to help this process, as well as another aspect. We're trying to promote another opportunity. We are trying to promote in a few projects we're working with, is to include the novel food authorization procedure within the research project for the benefit of the community. Therefore, as much as possible, by avoiding the request of protection of industrial secrecy.
Thank you, Dario. I think these are good closing words. We are unfortunately out of time, so thank you for your to reflect on this matter. Thank you, Rosemary. Thank you, Sveinn, and thank you, Ine, and everyone involved. And everyone, thank you for attending. As I said, unfortunately, we are out of time, but don't worry, because this is only the first webinar of this series. We will continue with this probably over the next 1 or 2 years with different topics and subjects. We will begin next year with some consumer acceptance. And please follow the projects, NextGenProteins, ProFuture, Smart Proteins, SUSINCHAIN, to get more information on the upcoming webinars, as Mari just posted. So thank you, everyone, and have a nice day.
Thank you. Bye-bye.
Bye.